So far we have seen Fourier transform as well as Z transform. In this video, let's study about Laplace transform. The systems operate in time domain, so its performance is analyzed in time domain by means of differential equations. And sometimes it's challenging to solve those equations in time domain. So what we will do, we will convert those differential equations from time domain to a simple algebraic equations and then solve those equations, use inverse Laplace transform to get back the answer in the same format. Okay, and S is equal to sigma plus j omega, where j represents the imaginary and omega is nothing but the frequency. If sigma is equal to 0, then it's nothing but a Fourier transform. So in Laplace transform we solve a differential equation, and by using Z transform we solve a difference equation. So Laplace and Fourier transform both are continuous version, where Z transform is used in discrete version. In short, I can say Fourier transform of converting a time varying function in the frequency domain, Laplace transform for converting a time varying function in the integral domain, and Z transform are similar, but it's a discrete time interval conversion. And this is the definition of Laplace transform. If f of t is a real valued function defined for all t greater than or equal to 0, then the Laplace transform of f of t is denoted by L of f of t, and this is nothing but integral t is equal to 0 to infinity e power minus st f of t dt, provided the integral exists. And this is the notation L of f of t is equal to f bar of s. Sometimes we will write this as f of s also, capital F of s. Okay, and s is nothing but a complex frequency, and this is the inverse notation. L inverse of f bar of s is equal to f of t. And now if you see this e power minus, this term makes the convergence easier because this is an exponentially decreasing function, and in real world problems convergence is not an easy thing. So if you multiply with e power minus st, the convergence becomes easier here. And suppose if f of t is a discontinuous function, say it's f1 of t in the interval 0 to a, f2 of t from a to b, and f3 of t for t greater than b. So in that case, integral 0 to infinity e power minus st f of t dt, we'll split it into three terms. Same, 0 to a first function, a to b second function f2, and b to infinity third function f3. So we are multiplying by e power minus st dt. Okay. Now let's see some basic problems. Find the Laplace transform for the function f of t is equal to sine 2t in the interval 0 to pi and 0 for t greater than pi. So this is a discontinuous interval. This is a general formula, 0 to infinity e power minus st f of t dt. So e power minus st, from 0 to pi my function is sine 2t, and from pi to infinity my function is 0 here. So e power minus st sine 2t from 0 to pi, and from pi to infinity e power minus st 0 dt. So this term will become 0, and this is nothing but e power at sine bt format. What is the formula? E power at by a square plus b square into a sine bt minus b cos bt. In the place of a I have minus s, in the place of b I have 2. So just replacing it, we get e power minus st by minus s square plus 2 square minus s sine 2t minus 2 cos 2t, the limit 0 to pi. Now you have to apply upper limit as well as lower limit. And we know that cos 2 pi is 1, and cos 0 is also 1. Sine 2 pi as well as sine 0 is nothing but 0. So we got this answer, e power minus s pi into 2 minus 2, and this is nothing but minus e power 0 is 1 when we apply the lower limit. So minus 1 by s square plus 4. Now we are going to see Laplace of some standard functions. For example, if I take Laplace of a constant a, what is the formula? 0 to infinity e power minus st f of t. My function is nothing but a constant, so I have written a dt. So keeping that a outside, e power minus st, if I integrate with respect to t, I get e power minus st by minus s, and the limits are 0 to infinity. And minus a by s we are taking it outside. When we apply the upper limit, e power minus infinity is nothing but 0, minus e power 0 is 1. So this minus and this minus will get plus a by s. So Laplace of any constant a is nothing but a by s. It's like if I say Laplace of 5, it's nothing but 5 by s. What is Laplace of 64? So it is nothing but 64 by s. And if it's Laplace of 1 is just a constant, so 1 by s. So this is the first formula that you have to memorize. And the second one is, let's see, Laplace of e power at. So according to the formula, integral 0 to infinity e power minus st into e power at dt. So I am taking minus common from here. So I will get s minus a t dt. I didn't integrate. Why I have taken minus common? Because infinity is there. So it's easy for me to apply the limit. So e power minus of s minus at by minus of s minus a. If I integrate, this minus of s minus a is just a constant, so it's coming in the denominator. That's it. Integral 0 to infinity. So when you apply the upper limit, e power minus infinity, it will become 0 minus lower limit. If we substitute, e power 0 is 1. 1 by minus of s minus a will be there in the denominator. So we get this. This and this will become plus. So 1 by s minus a. So Laplace of e power at is nothing but 1 by s minus a. What is Laplace of e power 3t? 1 by s minus 3. What is Laplace of e power 2t? 1 by s minus 2. What is Laplace of e power minus 2t? So 1 by s minus minus 2. So it will become s plus 2. So if I get a negative sign here, this will become positive. Say what is Laplace of e power minus 7t? I will write 1 by s plus 7. That's it. So now we know what do you mean by Laplace of a constant. Laplace of a is a by s. Laplace of e power at is 1 by s minus a. Now let's see this Laplace of cos h at. It's a hyperbolic function, right? So we are going to write the equivalent formula in exponential. So it is Laplace of e power at plus e power minus at by 2. Just now we got what is Laplace of e power at. Taking 1 by 2 common, we get Laplace of e power at plus Laplace of e power minus at. What is Laplace of e power at? Just now we have derived 1 by s minus a. Laplace of e power minus at is 1 by s plus a. So we are taking LCM. So s plus a plus s minus a divided by s square minus a square. Because this is a plus b, a minus b format. So in the numerator, if I simplify, plus a and minus a will get cancelled. I'll get 2s by s square minus a square. 2 and 2 will get cancelled. So we get s by s square minus a square. Similarly, we can solve Laplace of sin h at. So in sine hyperbolic function, we will get because e power at minus e power minus at, correct? So s will get cancelled. In the numerator, I will get a by s square minus a square is a formula. You can try to find Laplace of sin h at by yourself. If anyone is still struggling to write the sine hyperbolic function, sin h at is e power at minus e power minus at by 2. That is a formula for sine hyperbolic. Now let's see Laplace of cos at and Laplace of sin at. So now we'll try Laplace of sin at. So integral 0 to infinity e power minus st sin at dt. Because my function is sin at, I have written this over here. And just now we have seen in the previous problem also what is e power at sin bt formula. I am just using the same formula. In the place of a I have minus s, in the place of b I have a. That's it. Therefore, we get minus 1 by s square plus a square into e power minus st into s sin at plus a cos at. We have taken the negative sign outside. and then we are going to apply the limit, that is integral 0 to infinity. So e power minus infinity is 0 and e power 0 is 1, and here sin 0 is 0 and cos 0 is 1. So I got this minus a inside and already one more minus is there outside. So I got a by s square plus a square. And see in this formula whether it's e power at sin bt or cos bt, denominator is going to be the same, s square plus a square. Okay, so Laplace of cos at is nothing but s by s square plus a square. You can solve it on your own. And hope you know the formula for integral of e power at cos bt. What is the formula? E power at by a square plus b square, a cos bt plus b sin bt. That is an easy formula. Only for sine we have a negative sign over here. That's it. Now let's see Laplace of t power n. What is the formula? Integral 0 to infinity e power minus st. My function is t power n, so I have written t power n dt. So e power st is there, right? So I am going to take st as some value x, integration by substitution. Therefore dt will become dx by s. Okay, and Laplace of t power n now will become, and limits are same. If t varies from 0 to infinity, x also varies from 0 to infinity. Therefore we get e power minus x, here it is, t power n. T is nothing but x by s power n. Dt is nothing but dx by s. We have changed completely in terms of x. And s power n is just a constant. Here s power 1 is there. These two together will become s power n plus 1. Throwing it outside. And what we have inside integral 0 to infinity e power minus x power n dx. And this is nothing but the gamma of n plus 1. Remember, you have studied the formula for gamma of n. N is nothing but integral 0 to infinity e power minus x into x power n minus 1 dx. Since here it is n, we have gamma of n plus 1 in the numerator. So gamma of n plus 1 by s power n plus 1. It's just a formula. Whatever we have here is nothing but gamma of n plus 1. So hence Laplace of t power n is equal to gamma of n plus 1 by s power n plus 1. This is not root. We have to write like this. Just 2 lines. That's it. Okay. So gamma of n plus 1, we know that it's n factorial if n is a positive integer. So in such cases we can use Laplace of t power n is n factorial by s power n plus 1. So we'll be using it, this formula, only when n is a positive integer. Say Laplace of t power 3. So 3 factorial divided by s power 3 plus 1. That is 3 factorial divided by s power 4. What is Laplace of t power 4? 4 factorial divided by s power 4 plus 1. So 4 factorial divided by s power 5. Okay. So we'll be using this only when n is a positive integer, or else we'll be using this gamma of n plus 1 by s power n plus 1. Now these are the formulas that we have to memorize. We have seen this. What is Laplace of a? A by s. Laplace of e power at is 1 by s minus a. Here I have written the function. Here I have written the Laplace of that function. Cos h at is s by s square minus a square. Cos at is s by s square plus a square. Remember the logic why we got a negative sign here? Because hyperbolic. E power at, e power minus at. The formula is a combination of plus and minus. That is why a plus b, a minus b, denominator a square minus b square is coming. Because in the examination you will get a doubt whether it's a positive or negative. You may get confused between these two. Numerator is the same. For cos, the numerator is s. And in the hyperbolic, it's s square minus a square in the denominator. Normal cos term, s square plus a square because of the formula. Same way for sine hyperbolic, I clearly told if it's hyperbolic, denominator is a square minus a square, numerator a. We derived it. Similarly, sine at, numerator is a, but denominator is a square plus a square. And Laplace of t power n, just now we saw gamma of n plus 1 by s power n plus 1. But when n is equal to 1, 2, 3, in that case I can use the formula n factorial by s power n plus 1. Now these are all some warm up problems. What is Laplace transform of 3 sin h2t? So sin h2t means 2 by s square minus 2 square. Already this 3 is there. So 3 2s are 6 by s square minus 2 square is nothing but 4. Laplace of 3 into e power 4t. 3 is just a constant. E power at, what is the formula? 1 by s minus a. So 1 by s minus 4. In the place of a I have 4, I have written it. 3 is just a constant. It's in multiplication. If it's in addition, then I have to apply Laplace for 3 also. Okay. And Laplace of root t. So this is important because root t is nothing but Laplace of t power 1 by 2. So here n is not a positive integer. N is not 1, 2, 3, 4. So I have to use this gamma function formula only. So gamma of n plus 1, 1 by 2 plus 1 by s power 3 by 2. Okay. So because the formula is gamma of n plus 1 by s power n plus 1. 1 by 2 plus 1 is nothing but gamma of 3 by 2 by s power 3 by 2. Gamma of 3 by 2 is nothing but using gamma function 1 by 2 into gamma of 1 by 2. I can write like this. N into gamma of n minus 1. Remember that? We have used this. So gamma of 1 by 2, what is the value? Root pi. This you might have studied already. So gamma of 1 by 2 is root pi. Keep this in mind. So if you get anything in fraction, you can just reduce it till root gamma of 1 by 2 and you can finally replace gamma of 1 by 2 by root pi. If it's gamma of 5 by 2, what I will write? Then again I will reduce it 5 by 2 gamma of 3 by 2. Then again gamma of 3 by 2 I can write it as 1 by 2 gamma of 1 by 2. I can split it. So please try to remember this formula alone. This is more than enough. Gamma of 1 by 2 is root pi. Okay. So denominator remains the same. So we are going to use two formulas. What are the? Gamma of 1 by 2 is equal to root pi and the other one is gamma of n plus 1 is equal to n into gamma of n. That is why 1 by 2 into gamma of 1 by 2. We have used this. Gamma of 1 by 2 is root pi. Okay. Now see this, find Laplace of 3t plus 4 the whole cube plus 5 power t. Okay, this is 5 power t. So you have to deal it in a separate way. First we will expand this, a plus b the whole cube. So we got 27t cube plus 108t square plus 144t plus 64. And finally that 5t is this e power log of 5 power t. So e power log of 5 power t, what you will write? E power t log 5. Same thing we have written. So whenever you see certain terms like this, then e raised to the power log. So I will write e power log of 5 power t. So log of m power n is n log m. So the t comes down. So e power log 5 into t. Now you can apply Laplace transform. Because t cube, what is the formula? Just leave those constants just next to it. T cube is 3 factorial by s power 4. Just now we saw Laplace of t power n is n factorial by s power n plus 1 when n is equal to 1, 2, 3, etc. Correct? And 108 into t square is nothing but 2 factorial by s power 3. One term extra than this we will write in the denominator. Plus 144 into t. T is 1 factorial by s power 1 plus 1. So s power 2. And this is just a constant. So 64 by s. Remember Laplace transform for constant is a by s. Here a is 64, so 64 by s. Plus finally what is Laplace of e power at? 1 by s minus a. So 1 by s minus log 5. Okay, 1 by s minus log 5. The place of a I have log 5. This is 80. This log 5 is nothing but 80. So what is Laplace of e power 80? 1 by s minus a. So I have written 1 by s minus log 5. So study the formulas and try to bring down to the formula format if it is not there. For example, this 5 power t, I brought it to e power at formula format, and then before applying Laplace of t power n, check if n is 1, 2, 3, then you can apply n factorial by gamma of n plus 1, n factorial by s power n plus 1. If not, then we will be using gamma of n plus 1 by s power n plus 1. Let's see more problems in the next video. Thank you.